Something terrifying has just emerged in China, and it is forcing the world's biggest automakers, Toyota, Honda, even Tesla, to wake up in the middle of the night and rethink everything they are doing. It is not a new car model. It is not some massive investment announced with flashy headlines. It is just one technical number and a statement about a new engine. But that number is shaking a belief the global auto industry has spent nearly a decade building, that the future of cars can only be electric, that internal combustion engines are finished, and that the next battle is simply about who can build better batteries and charge them faster. And it all comes down to a completely new hybrid engine from Geely, a name that has risen rapidly over the past few years. So here is the question. If a hybrid vehicle can travel more than 2,000 kilometers on a single tank of gas, do people really still need to stand around waiting at charging stations? And if China, a country once labeled as nothing more than a maker of cheap products, is the place where this breakthrough happened, what does that say about the technological position it has been quietly building? Those two questions will guide us through today's story, and the answers could redraw the entire power map of the global auto industry. Hit subscribe to support us, because making a detailed video like this takes an incredible amount of work. Let's get started. China's Geely has just announced a new hybrid engine with a thermal efficiency of 48.41%. At first, that might sound like nothing more than a dry technical statistic, but for engine engineers around the world, this number feels like a real shock. For decades, gaining even a few extra percentage points in thermal efficiency has been an exhausting battle. Reaching nearly 50% was once considered almost impossible for a mass-market hybrid internal combustion engine. To understand why this number is so frightening, we need to understand what thermal efficiency actually means. When fuel burns inside an engine's combustion chamber, not all of that energy turns into power that moves the car forward. A huge amount is lost as heat escaping into the air, friction between mechanical parts, vibration, and countless other losses that you cannot see with the naked eye. Imagine putting 100 units of energy into an engine. If its thermal efficiency is only 30%, then only 30 units actually push the vehicle forward. The other 70 are basically wasted and released into the atmosphere. That has always been the built-in weakness of older gasoline engines. In many previous generation vehicles, thermal efficiency hovered around just 20 to 25%. In other words, more than half of the gas pumped into the tank was almost wasted, never truly converted into driving range. That is exactly why older cars burned through fuel faster and traveled shorter distances using the same amount of fuel. The first company to truly change the game was Toyota. When the Japanese automaker introduced the Prius, the world saw for the first time how a smart combination of a gasoline engine and an electric motor could take fuel efficiency to an entirely new level. Toyota gradually pushed the thermal efficiency of its hybrid engines to around 40%, and at the time, engineers viewed that as a major technological achievement. It meant the engine wasted far less energy than earlier generations, allowing Toyota's hybrid vehicles to travel much farther while using the same amount of fuel. At the same time, Honda was not standing on the sidelines. The company became known for refining its engines down to the smallest detail, focusing on smooth performance, long-term durability, and outstanding fuel economy. Honda worked on lighter components, improved its hybrid powertrain, and developed smarter energy management systems, helping its vehicles become a benchmark for reliability for many years. But now, Geely says it has reached 48.41%. At first, the gap between 40% and 48% might not sound that huge, but in the world of engine engineering, the closer you get to the limits of physics, the harder every single percentage point becomes to achieve. It is like cutting a 100-meter sprint from 10 seconds to 9.8 seconds, not just doing simple subtraction. At this level, nearly half of the fuel's energy is actually being turned into force that moves the wheels, instead of being burned away as wasted heat. So how did Geely achieve something that many long-established auto giants still have not reached? The answer is not one single invention. It is a carefully engineered stack of technical improvements working together. First, there's an extremely high compression ratio. Inside the cylinder, the more tightly the fuel and air mixture is compressed before ignition, the more powerful the combustion event becomes, and the more energy can be extracted from the fuel. But there is a problem. The higher the compression, the greater the risk of engine knock, uncontrolled and unstable combustion inside the chamber, which can damage the entire engine. Geely has added an advanced anti-knock control system that allows the engine to run steadily even at very high compression levels, making every drop of fuel produce more useful power. Next comes an incredibly precise fuel injection system. In older engines, fuel delivery was often not optimized. Sometimes too much fuel was injected, which meant part of it did not burn completely. But in Geely's new engine, fuel injection is calculated down to the smallest detail. The right moment, the right amount, almost like a skilled chef adding the exact number of grams of seasoning needed for a dish. That makes combustion more complete and cuts fuel waste to a minimum. Then there is the redesigned combustion chamber, which helps the fuel burn more evenly. Instead of letting combustion happen in a chaotic way and produce excess heat like before, Geely has made the combustion event far more stable and uniform. That means more energy reaches the wheels instead of escaping as wasted heat. This is considered one of the most important reasons why the engine's thermal efficiency has climbed so high. Another factor may sound minor, but it plays an extremely important role: reducing friction between mechanical parts. In older engines, countless components constantly rub against each other, and a noticeable amount of energy is lost just overcoming that friction. Geely has used specialized materials and coatings inside the engine to reduce friction significantly. Think of it this way: dragging a heavy object across rough ground takes much more effort than pulling it across a smooth floor. That extra smoothness allows the engine to run more easily and use less fuel. But the most groundbreaking part may be the artificial intelligence-based engine management system. Traditional engines tend to react according to a mostly fixed pattern, whether the car's driving through crowded city streets, cruising on the highway, or climbing uphill. This new system constantly gathers real-time data. It tracks how hard the driver accelerates, road conditions, remaining battery charge, and current fuel consumption, then automatically adjusts the engine's operation for that exact moment. In a hybrid system, the internal combustion engine does not always carry the full load. Sometimes the electric motor steps in to help. Other times, the battery gets recharged through regenerative braking. This allows the gasoline engine to spend much more of its time operating in its most efficient range. What may be even more thought-provoking is how China achieved this step forward in a relatively short period of time. Just a few years ago, the common image of China's auto industry was cheap assembly plants and products accused of copying technology from elsewhere. But that picture has now changed completely. Companies like Geely are pouring billions of dollars into research and development, bringing together artificial intelligence specialists, software engineers, and advanced automotive laboratories working side by side. And that may be what worries Toyota, Honda, and many other long-established automakers the most. In the past, competition with Chinese brands was mainly about price, but now the race has moved to an entirely different battlefield: core technology. So where does the claim of more than 2,000 kilometers on a single tank of gas come from? And is it really possible? The answer lies in the smooth coordination of three parts: a highly efficient gasoline engine, a small but intelligent battery pack, and regenerative braking. First, the high-efficiency gasoline engine can now extract far more useful energy from every drop of fuel than previous generations could. While an older vehicle might only travel around 12 to 15 kilometers per liter of gasoline, a modern hybrid system can go much farther using the same amount of fuel. That is because the engine is no longer designed just to make power. It is designed to manage energy intelligently. Then there is the battery pack. Many people assume that because a hybrid battery is small, its contribution must also be small. But the reality is different. At low speeds while driving through the city, or when stuck in traffic, the electric motor handles much of the work of moving the car. That means the gasoline engine does not have to carry the full load all the time, and fuel consumption drops significantly. And the final piece of the puzzle, the quietest weapon of all, is regenerative braking. In a normal car, when you hit the brakes, all of the vehicle's kinetic energy turns into heat and disappears for nothing. But in a hybrid, that braking energy is captured and sent back into the battery. In other words, fuel is no longer the only source of power, because the system is constantly reusing energy that used to be wasted. Let's do some simple math. If a hybrid vehicle can achieve around 35 to 40 kilometers per liter of gasoline and has a fuel tank with a capacity of 50 liters, then in theory, it could travel roughly 1,800 to 2,000 kilometers on a single full tank. That is exactly what could become a real challenge for fully electric vehicles. While EV drivers are still trying to find a charging station, hybrid drivers can keep going without stopping, especially in countries where charging infrastructure is still limited and not fully developed. For many people, this is no longer just a backup option. It is starting to look like a practical choice worth seriously considering. Looking back over the past 20 to 25 years, hybrid technology has always been closely associated with Japan. Toyota has been seen as the undisputed king in this field, while Honda has built its reputation on precision engineering, durability, and smooth performance. The core strength of Japanese automakers has always been their deep investment in every tiny detail of the engine, and that is why, for years, the rest of the world viewed Japan as the leading model for efficient engine technology. But now, that picture is slowly beginning to reverse. Chinese companies are no longer focused only on electric vehicles. They are also setting new records in hybrid technology itself, a field that was once considered Japan's untouchable home ground. Geely's engine with a thermal efficiency of 48.41% is not simply a new product. It is a direct challenge to the dominant position Japan spent decades building. The very technology Toyota took decades to refine is now becoming a field where China says it is moving ahead. That may explain why, even though Japanese automakers appear calm on the outside, the machinery inside their research departments is almost certainly speeding up at full power. In the auto industry, the scariest thing is not losing market share in the short term. It is losing technological leadership. Once the market starts to feel that real innovation is coming from somewhere else, a brand's image can slowly wear away over time. That is probably why many experts believe Japanese automakers are quietly preparing their next generation of strategy. It could mean even more advanced hybrid systems. It could mean accelerating research into solid-state batteries. Or it could mean taking artificial intelligence-based engine management systems to an entirely new level. Because if they do not react fast enough, their leading position in the market could gradually slip into the hands of competitors. China's biggest advantage in this race is speed of decision-making. With government support, a strong domestic supply chain, and enormous investment, new technology can be developed and brought to market much faster than through traditional methods. Meanwhile, Japanese automakers are used to testing technology for years before releasing it, putting reliability above everything else. That is why Japanese cars have been considered dependable and durable for generations. But in a fast-moving market like today's, that caution can sometimes become a weakness. The next question, and probably the most controversial one right now, is whether this ultra-efficient hybrid technology could become a warning sign for the electric vehicle industry itself. For years, the world has been given an almost absolute message. The future belongs only to electric vehicles. Tesla, BYD, Hyundai, and nearly every major corporation have poured billions of dollars into EV development, while many governments have openly discussed gradually phasing out gasoline-powered cars. But now, as highly efficient hybrid engines like this begin to emerge, a new question is starting to enter consumers' minds. If a hybrid vehicle can travel more than 2,000 kilometers, use very little fuel, and remove the stress of finding a charging station, will buyers still seriously consider choosing a fully electric vehicle? The real strength behind China's progress is not one engine alone. It is control over the entire supply chain. The world once assumed China was only good at making cheap cars, but behind the scenes, the country has quietly built control over almost every major link in the automotive industry, from batteries, semiconductor chips, and electric motors to hybrid systems and control software. When batteries, chips, motors, and software are all produced domestically, import costs go down, transportation costs are reduced, supply becomes faster, and companies no longer have to depend on foreign countries for every small component. That is the deeper reason Chinese companies can cut prices so aggressively while also rolling out new technology at such an incredible pace. So, how will the rest of the global auto industry respond to this wave? Tesla is still firmly committed to its all-electric strategy. and Elon Musk has repeatedly said that the future belongs to electric vehicles. But if hybrid technology becomes efficient enough to offer operating costs close to those of an EV while keeping the convenience of a gasoline-powered car, then the pressure on Tesla will definitely grow. Consumers would suddenly have another practical option to seriously consider. BYD, meanwhile, is in a very interesting position because it is developing both electric vehicles and hybrids at the same time. If demand for hybrids rises in the future, Chinese companies appear to be ready for that scenario already, and that could become a major challenge for the rest of the industry. At the same time, traditional names like Hyundai, Ford, and Volkswagen have invested heavily in shifting toward electric vehicles over the past few years, from redesigning factories to building entirely new EV platforms. But if the market unexpectedly starts leaning back toward hybrids, they may be forced to rebalance their strategies. This shows that in the years ahead, automakers may no longer be able to focus on just one direction. They may need to pursue both paths at the same time. In developed countries, where charging infrastructure is already relatively well established, the shift toward electric vehicles could still move forward quickly. But in many developing markets, where buyers still care most about practicality, low costs, and convenient refueling, hybrid technology could easily become the winning choice. That is why many major companies may be quietly returning to hybrid investment, even while publicly continuing to talk about an all-electric future. This also points to a deeper shift in how the world sees China. China is no longer viewed simply as a low-cost manufacturing hub that copies technology. It is now competing directly in research, artificial intelligence, software, batteries, semiconductor chips, electric motors, and the supply chain for the entire auto industry. If this pace of innovation continues, then it will not just reshape the car market. The global balance of technological power in this field could also move in a completely different direction from what people once imagined. Maybe the most interesting part of this whole story is that the competition is no longer as simple as electric cars versus gasoline cars. The auto industry seems to be entering a mixed era, where electric vehicles, highly efficient hybrids, and internal combustion engines pushed to their limits all exist side by side and compete directly on the same playing field. The company that can deliver lower costs, longer driving range, and fewer inconveniences for everyday users will most likely take the lead in the next phase of the industry. So the final question is for all of us. As battery technology becomes cheaper and internal combustion engines become more efficient than ever before, which technology will consumers around the world truly put their trust in over the next 5 or 10 years? The answer is probably still being written right now, inside laboratories that remain lit through the night in Japan, China, Europe, and the United States. If you find stories about automotive technology, the race between electric vehicles and hybrids, and the hidden forces shaping the global auto industry as fascinating as we do, subscribe now so you do not miss the next updates.